All right, let's dive right into some of the most fundamental building blocks in Python. Its core data containers. We're going to break down lists, tuples, and dictionaries, so you know exactly how and, more importantly, when to use each one.
Think about it. Your code is just bursting with data, right? You've got shopping lists, user profiles, game scores, and how you choose to store all that stuff. It's not just some minor detail. It can actually make or break your program's performance, its safety, and even how easy it is to read. So let's find the right tool for the job. Okay, so first up, let's talk about the one you'll probably see the most, the list. Seriously, the easiest way to get your head around it is to just picture a shopping list. You know, something that's designed to be changed, updated, and reordered as you go. Now, if we get a little more technical, a list is basically just a sequence of values. But the cool thing is, those values can be anything. Numbers, words, even other lists. Just keep an eye out for those signature square brackets. That's how you know you're looking at a list. But if there's one word you need to remember about lists, it's this. They are mutable. This concept is everything. It's the whole reason lists exist. So, mutability. What does that even mean? Well, it's pretty simple actually. It's the power to change things in place. This means you're not making a whole new copy of the list every single time you edit it. Nope, you're changing the original right where it lives in your computer's memory. It's super efficient for data that needs to, evolve. Let me show you what I mean. Say we've got this list here. We can just target an item using its position, its index, and boom, give it a new value. The original list itself is changed, just like that. It's literally built for this kind of on-the-fly flexibility.
All right, so we've got a handle on data that's supposed to change. But what about the opposite? What about data that absolutely positively must not change? For that, Python has another tool for us, tuples.
And you might be thinking, hold on, why would I ever want a container I can't change? I mean, lists are so flexible, right? It totally sounds like a bug, not a feature. But trust me, it's actually a superpower.
You want something you can't change to protect your really important data from getting messed up by accident. Think about it. Map coordinates for a specific place, someone's date of birth, a scientific constant. You don't want some other part of your program accidentally nudging a city a few miles to the left, right? A tuple is like a digital lockbox for your data.
And that superpower has a name: immutability. A tuple is what we call an immutable data type. You just can't make changes in place, and you'll always spot them by their parentheses.
So just watch this. What happens if we try to treat a tuple like it's a list? We set it up, we try to change that first element, and bam! Python throws up a wall. You get a type error.
And I really want to drive this point home. That error, that's not a bug. It's 100% a feature. That's Python doing its job, protecting your data just like you asked it to, making sure it stays constant and reliable.
Okay, let's do a quick head-to-head. Lists are mutable, they can change. Tuples are immutable, they're locked in. And here's a cool little bonus. That difference actually makes tuples faster. Since Python knows a tuple will never change, it can be a bit more efficient with it.
All right, so far everything we've looked at, lists and tuples, we find stuff by its position, its numerical index. But what if you don't care about the position? What if you want to look something up using a name or a label, like finding a phone number by searching for a person's name? For that job, we need our third container, the dictionary.
A dictionary is totally different. It stores information in pairs, a key and a value. So instead of an index like 0, 1, 2, you make up your own index, a unique key. And you'll spot these by their curly braces.
Check out this class role here. To find Rakesh, we're not asking, what's in the second spot? No, we're asking, what's the value for the key 2? We're finding data by its name, not its place in line.
And this brings up a really interesting question, right? If we get to make our own keys, what can we use? Can a key be a list? Or maybe another dictionary? What are the rules here?
And this is where it all comes full circle. Dictionary keys have to be immutable. Think about it. A key is like a permanent label. It can't be changing all the time. So, what do we know that's immutable? Numbers, strings, and yep, you guessed it, tuples. You can totally use a tuple as a dictionary key, but a list, no way.
So there we have it, 3 different tools for 3 very different jobs. Let's wrap this up and put them all together in one spot so you know exactly which one to grab from your toolkit every time.
Okay, here it is, the ultimate cheat sheet. If you need a flexible collection that's going to change a lot, you grab a list with the square brackets.
If you have a constant record that you need to protect and maybe access super fast, you want a tuple with the parentheses. And when you need to store related info that you look up with a specific label, you reach for a dictionary with the curly braces.
You know, picking the right tool just makes the whole job easier, and your code ends up being way more reliable. So the next time you're coding, stop and ask yourself, does this data need to change? Does it need to be protected? Or do I need to look it up by a label? Which one are you going to reach for?